Hello and welcome to today's Range of 4 webcast. Today we're talking about the Rational Test Workbench. We'll be talking about integration testing and service virtualization. Our speaker today is Stuart Feasey of IBM. Stu, would you like to say hello and start your presentation?
Thanks, Helen. Yes, so my name is Stuart Feasey, now with IBM. Previously with quite a small company called Green Hat, which IBM acquired just over 2 years ago, primarily for its service virtualization capabilities, but we also do some very useful things around middleware testing, testing message inputs and outputs to complex middleware systems without any dependencies on user interfaces, and we also have a very strong hook into continuous testing, continuous integration solutions, and DevOps. So I'm going to talk to you about the entire Green Hat testing suite that IBM acquired. All the products have been blue washed, but you'll still commonly hear the software referred to as Green Hat. It's just a name that's stuck. Essentially, IBM has packaged the Green Hat offerings up into what's called Rational Test Workbench. But everybody still calls it Green Hat, so please feel free to refer to it in that sort of framework. So what's the software about? Essentially, testing complex middleware solutions has traditionally been a bit of a headache. You can have several different layers of technology that don't necessarily bear any particular resemblance to each other, and the hooks into the various endpoints within a middleware environment typically rely on some kind of middleware messaging format, something like HTTP web services, maybe WebSphere MQ, flavors of Java messaging services, etc. We've also got, obviously, dependencies on things like databases, several sort of proprietary ESB solutions could be in the mix. So lots of different things, essentially. And what we're looking to do with a middleware testing platform is keep a track of the message as it traverses the middleware architecture and place validation points on all the important areas so that we make sure the system is communicating properly. And when problems occur, we can identify them quickly and easily, very quickly come to the conclusion that we need to fix a particular part of the system rather than spend time trying to recreate test data, recreate problems, etc. That's really what the Green Hat software is about. We need to be able to make sense of whatever technology exists within a complex middleware environment in order for us to integrate with it, to drive test data in, and also to validate what's coming back out. Now, the service virtualization piece comes in where you potentially have pieces of your middleware architecture missing. And that could be because things aren't available yet, or it could be because you've got expensive business partner message feeds that you'd like to remove dependencies on earlier in the life cycle in development and test environments, for example. What we're looking at on this particular diagram is essentially 3 different stakeholders that are invested in this middleware architecture. They each need to be able to test against the various components that make up this architecture. Now, typically, if one of these stakeholders decides that they would like to change any of the components within the architecture, that can cause problems for the other stakeholders because they'll essentially be seeing differences coming back. They may be driving the same regression tests in. Obviously, if someone else is changing the system, that will result in non-deterministic tests. It will result in test data coming back from the system that they're really not expecting to see. And this is where service virtualization comes in. Essentially, you can stub out pieces of the environment dependent upon different message payloads. So what I mean by that is we can essentially stand up a stub at exactly the same time as live service components, and we can route the traffic through to the stub dependent upon the contents of the message payloads. So you can get more value from your existing environments by using service virtualization in conjunction with existing services, or of course you can stub out those services altogether if they're not available for whatever reason. And we'll be talking more about service virtualization in just a second, but just to give you a handle on how we approach testing with the Green Hat technology, typically people would look to use the user interface if they're doing traditional sort of end-to-end testing of a middleware architecture. The user interface typically plays quite a strong part in that people will be entering data in through the user interface and observing the responses they get back through the user interface to give an indication of whether things are going well in the middleware architecture. Now, what we're suggesting is you're only really seeing the tip of the iceberg if you're taking that approach, because there's an absolute wealth of information that's available in the middleware platform. So if we just follow through a typical sort of user interface driven testing scenario, and this will hopefully illustrate the point. So I'd enter some data in through the user interface. I'd click the proceed button or the submit button, which would obviously result in the payload being delivered into the middleware architecture. But we might be calling out to other parts of the system, other components within our own architecture. We might be calling out to third-party business partners, doing credit checks, doing bank transfers, etc. We might be doing some database access before ultimately collating that information up to give a response back to the user interface. Now, in this case, it's been a perfectly successful test. We've seen that the result back to the user interface has been what was expected. The problems really occur when we get a non-successful result. And this is where Green Hat really can play a strong part, because we can place validation points on all the important areas within the middleware architecture, so that when something goes wrong, we can point you to exactly where the problem was encountered, rather than having to go and potentially speak to the integration team about analyzing logs or recreating the test circumstances and trying it again with some monitoring switched on, etc. All the validation that Green Hat does is provided in a transparent manner, so it's not going to interfere with the underlying system, and it will very quickly and easily build a report for you that tells you exactly where problems are occurring. And of course, you can drive that test data in through Green Hat as well, as I mentioned, without the dependency on the user interface. And that can give you a more sort of robust approach to developing systems, because you can essentially decouple the user interface stream of development from the underlying middleware architecture. And you can do end-to-end testing against the middleware transport without any need for the user interface being robust or available at any given point. Obviously, you're still going to need to do an end-to-end test through the user interface, but that can happen much later in the life cycle when you look to bring everything together. So just to illustrate what we've just seen, if we were using Green Hat to drive a payload into the system under test, we consume its output through the Green Hat GUI to observe the responses we've seen back from the system and validate that everything has occurred as expected. But of course, we can do more. We can do automated SQL queries. We can automatically place watches on all the interactions between the various components that comprise our own middleware architecture. We can also browse and validate any call-outs to third-party business partners to ensure that those things are behaving as we expect them to as well. So that's functional testing with the software in a very sort of introductory manner. But of course, that leads me into the service virtualization capabilities of the software. And here we're illustrating some of the reasons why there might be gaps in your middleware architecture. You're still waiting for pieces of the architecture to be deployed. We may have a very expensive third-party business partner test feed that you're looking to remove dependencies on. Essentially, anything that's causing components within the middleware architecture to be absent, we can spin up a stub or a virtual service so that you can essentially mimic what the live component is going to give you once it's online before you actually deploy it, to enable you to do end-to-end testing before you've actually got the full system stood up. This has a number of benefits. Obviously, it means you can begin testing things much earlier in the life cycle. But an important point is you can build the same test regardless of whether you have the underlying components online and reuse that throughout the life cycle. There's no need to go back and add in different areas to your test once you start deploying new pieces. You'll build the same test and it will have validity throughout the entire life cycle. So just to illustrate the point again, we're missing a business partner test feed here, but we can still do an end-to-end test because we can virtualize that call out and virtualize the response back to the system under test. Now, some of the technologies that we support are listed here. This is not an exhaustive list, but just to give you a sort of handle on things, since IBM acquired Green Hat, the focus has been mainly on sort of bringing the support for IBM's middleware technologies completely up to standard. There's not to say it was lacking before, but we've added some additional capabilities in around mainframe support, so we can now virtualize things like KICS and IMS interfaces. Of course, we have very strong support for WebSphere MQ, as well as things like TIBCO BusinessWorks, various flavors of JMS, and of course, common open standards like HTTP web services, JSON interfaces, SOAP, etc. An important point to make is we have several message formatters built into the product. Typically, some of the tools come from a development background. We might not have deep familiarity with lots of different message formatters, message formats that are used within middleware architectures. The tool aims to make their lives a bit easier, essentially by giving a unified editor for all of these different message formats, so that you can very quickly and easily make sense of message payloads, create new test data, etc., without having to understand what the message structures look like and the syntactical rules of those messages. So if we step through how people might typically be doing their testing at the moment prior to adoption of Green Hat tooling, people will very quickly, developers will very quickly go from the requirements gathering phase into writing units of code and doing individual unit tests. So we'll have several developers writing code, unit testing that code. They may have found that some of the requirements are not completely robust. They may have had to adjust some of the message interfaces. So that when we look to bring our code together with our colleagues, when we deploy our code, we can end up with some problems, some niggly issues around interfaces. Perhaps the interfaces don't marry up exactly as we'd expected them to. And this can lead to this big bang scenario, ultimately, where we get a whole load of code deployed all at once, and we have to sort through the problems to make the code interact, essentially, over the middleware transports. This can result in a fairly lengthy period of system testing, but we're not actually system testing. What we're doing is actually sorting through these interface issues and the niggly problems that are preventing an end-to-end test from occurring, which can result in fairly late cycle performance testing. Obviously, we can't really performance test until we've got a system that is represented in a joined-up fashion, which will potentially put us under pressure as we're looking to get into user acceptance testing. And obviously, any performance-related issues discovered late in the cycle, they're fairly difficult to unpick. They're quite baked in by this stage. And ultimately, we'll get into operational acceptance testing. So we get this big bang scenario introducing multiple defects all at once. Lots of risk because we don't really know how long it's going to take to sort through interface issues and get the system fully represented. And it can be quite an expensive way of doing things because we really don't know how long this cycle might take. So how does the Green Hat technology look to address these issues? Well, the first thing to mention is obviously requirements gathering. We all know that defects born from requirements are the expensive ones to fix. The tool will help in some respects in this area, but robust requirement gathering is a bit of an art form in and of itself. So the tool, doesn't really do a huge amount there, but it's definitely worth mentioning if we're looking to speed up this cycle. What we can definitely assist with is spinning up stubs that represent what our developers are working on prior to the code actually going live. So if you imagine the scenario, if I'm a developer, I'll take the requirement specifications, which will probably include interfaces to whatever services I'm building. I can very quickly turn those interface specifications into a stub. The tool makes that very quick and very easy. So I can actually place a stub online for other people to interact with. It might not have a lot of logic in it in the initial phases, but of course people will be able to integrate with that and test their code and call my code across the middleware transports. So we're essentially beginning integration testing, and we're resolving interface issues much earlier in the cycle, which will result in a shorter period of system testing, which ultimately results in a shortened life cycle. And you'll notice performance testing as well can begin much earlier in the cycle too, because we can attach non-functional requirements to our stubs to ensure that they respond in the same kind of time frames that you're looking for the live system components to respond in. So you can effectively begin performance testing against the pieces you're actually deploying much earlier in the life cycle, resolve performance-related issues before they become baked in and difficult to address. So we obviously get accelerated testing for reducing costs, but most importantly, we're lowering risk, because by turning our requirements into physical representations much earlier, we're actually getting an embodiment of the requirements to work against, so that when things change in the requirements, they're very quickly represented in the live system, even before you've actually written the code, which obviously results in much greater transparency about where we're headed with the deliverables. Now, a few points here, and I'm not going to go through each and every one of these, but essentially a few important points about our service virtualization capability. There's absolutely no need to write code to build stubs. All of the stub building is achieved through a drag and drop GUI-based environment. You can very quickly turn interface recordings, so we can record traffic that goes across middleware transports, very quickly turn those recordings into stubs. Or of course, you can build stubs directly from the message interfaces, as I've just illustrated. You'll potentially take an XML schema or a WSDL document that defines what legal payloads coming in and coming out of our components look like, and you can very quickly turn those things into stubs. All the tools for creating and maintaining the stubs, they're all included within the GUI-based product. Essentially, we make life as easy as possible. We recognize that testers and developers, they don't want to spend time maintaining and building tests, so we do everything we can with the tool to make that process quick and easy. We also offer links into all the major quality management tooling. So things like HP Quality Center and Rational Quality Manager. You can use those interfaces to drive your test cases through and observe all of the reports that the Green Hat software produces through those common interfaces. So you can still leverage those tools if you have them in your environment. We also have hooks into major defect tracking systems. So when you encounter defects in your testing, you can raise a defect very quickly and easily through the GUI product, through Rational Integration Tester, and embed a deep link back to Rational Integration Tester into your defect tracking system. So when a developer comes to look at addressing the problem, he can essentially click on that deep link, and it will open a copy of Rational Integration Tester, so he can see exactly what the tester saw when they ran the test, including all the test data and the detailed report that was produced. We also have very strong hooks into continuous delivery solutions. All of the test suites, including stubs, you can integrate those into your continuous delivery solutions so that when you run overnight builds, a build and deploy routine, for example, we can automate a regression test occurring at the end of that cycle. And that will obviously give you the information you need to decide in an automated fashion whether that build will remain in place. If enough tests fail, you may obviously choose to automate the rollback to the previous state before the build was actually deployed. So we integrate very well into tools like that. Just a quick sort of whistle stop through the various components that comprise the Green Hat technology. We've spoken about the Workbench product already. That's essentially the GUI, where you'll build tests, where you can record traffic, where you'll build and maintain stubs, etc. We also have two test servers. We have a virtualization server. The virtualization server gives you a long-running capability for stubs. So if, for example, you want to run a stub to completely remove a dependency on a third-party business partner in a development environment, you would run that through the virtualization server. And you get a very clear indication of which bits of the system are virtualized through a standard control panel, which is essentially a web page that anybody in the team can log into. Removes any confusion at all about which bits of the system are virtualized and which bits are real. We also have a performance test server. The performance test server is there to drive load into the system in an orchestrated fashion. It's a dedicated piece of hardware because obviously if we're looking to achieve large load against the system, we can't always be sure that somebody running the Workbench product, the GUI-based product, is going to have a powerful enough machine. So we always recommend a dedicated server for that. So I'm going to show you how quickly we can turn some recordings into a stub, how quick and easy the software makes that process. Just to introduce you to what you're about to see. Essentially, we've built a demo application. We've built quite a noddy application to book a hotel, book a flight for our holiday. So this web-based interface allows me to enter my information, payment details, etc. to book a flight. But at the back end, what the GUI is actually talking to, what the web page talks to, is an MQ queue manager, which is linked into a WebSphere application server, which at the back end is speaking to a DB2 database. And all the application does essentially is issue an incremented reservation number back in its response message to the GUI. But this gives us a way of demonstrating how the Green Hat tooling can interface with these technologies and enable you to record traffic, build stubs, build tests, etc. So if I just step into my demo VM, my virtual machine, you'll see this is the hot air flight booking system that I've just sort of demonstrated at a high level. I'm going to book a flight to Barcelona from Stansted. And what we'll see when I click this proceed button is that we get a reservation number back in the GUI. And that is currently at 13. If I click it again, you'll see that increments to 14. So without dwelling too much on that particular piece, I'm stepping in now to the GUI-based product. This is Rational Integration Tester. You can see I've already got a model, a logical model of the system under test. So this is obviously the middleware architecture. So if you imagine the GUI is over here somewhere injecting a payload into this main booking operation. Based upon the payment, the card type that I've used, we access one of these three subroutines. You can see that there's a WebSphere MQ queue manager that's directing the traffic, and here's the underlying database. You get some insight into what the payload looks like, because through this logical view we can attach message schemas that tell us what the payload should consist of. You can also see here that we're using WebSphere MQ and some details about the various queues that are in play. So what I'm going to do here, this is just the logical view of the product. There are 6 perspectives that you can see across the top here. What I'm going to do is record the traffic coming into make booking, into the make booking operation, and we're going to see how I can turn that very quickly and very easily into a stub. So the first thing I've done is just clicked on the make booking operation. Now I'm going to click to register an event monitor against that make booking operation. And clicking that button has pushed me through into a different perspective within the tool. We're now in Recording Studio. So I'm given the option of recording at a more granular level, the various things that are going to our sub-processes and other sort of dependencies here. At the moment, I'm just going to record at the top level, just what comes into make booking and what comes back out. Starting this recording is just one other button click. You'll see in the bottom left-hand area that recording is now in progress. So that when I come back and click this proceed button again, you see that reservation number is incremented once more. But if we step back into Rational Integration Tester, you'll see that I've actually captured a copy, and this was completely obviously the GUI is still working as we expect it to. It's not as though the GUI didn't receive the response message back because we were recording things. So we've got the request and the associated response with the reservation number of 15 in there. So what I can do is highlight these 2 messages, click this save icon, and that gives me, essentially it throws up a wizard within the tool that guides me through the process of creating test assets. I can create a number of different things from these recordings. I could create unit tests. I can create things like operations, so I could build up a more detailed picture of the environment if I wanted to for the logical view that we initially started with. For now, I'm just going to record or create a stub from these 2 recordings. And again, the software guides me through this process. At the moment, I want to save just with hard-coded values to make this quite a simple demonstration. I could save the data out to an associated spreadsheet, or I could build a state-based data model so that I could maintain state within my stub. For now, I'm just going for hard-coded values. And actually, I'll just go directly to the summary, give my stub a name, click the finish button. Clicking this finish button is going to pass me through to another perspective within the tool, the test factory perspective, where I can, if I wish, embellish this stub, change its behavior slightly, make it more generic than it currently is. At the moment, you can see there are several filters on the request message. And filtering is essentially how we decide what to give back in our response. So if I wanted to build a very generic stub, I would want to switch off all of these filters, which I'll just do. So I'm going to change the filtering to switch off equality checking, and just make sure that all the fields do exist, because all those fields are actually mandatory. So that's the only thing I'm going to check for, that all the fields exist. Save the stub, and I can run the stub just with another click of a button. So we're now passed into test lab, the perspective of the tool. So what we're aiming to do here is really sort of abstract out the various tasks that we're looking to achieve with the tool and make it as simple as possible to understand what we're doing. So when I come back now and I click the proceed button again, what we'll see is the number has stopped incrementing. because essentially we're no longer interacting with the underlying system under test. We're now interacting purely with the stub because I've switched off all the filtering, so there's no content-based routing in place. So the stub is giving us responses to absolutely everything we see. And we'll see here we've hit the stub twice. It's a very small number, so I'm not sure how well you can see that. But we've essentially generated 2 response messages in the console log here. If I wanted to change this stub, it's a very simple process, and I'm just going to change the output to remove any doubt whatsoever that the stub is actually responding instead of the live system. And I'm going to put a date timestamp in the response instead of that reservation number. So if I save my stub, the tool automatically recognizes that an instance of the stub is already running, so it's just offering to restart it, which is fine. So back into Test Lab, see the stub is running once again. If I click the proceed button now, you'll see that we get that date timestamp back instead. I mentioned content-based routing, where we can potentially have the stub running at exactly the same time as live system components. I'm just going to show how easy that is to achieve. So in my input message, remember I switched off all the filtering. I'm going to switch on filtering based upon the payment type. So I'm just going to check for equality on Maestro. So essentially what this is doing is telling the stub that it only needs to deal with Maestro payments now. All the other filters are still off. So when I rerun this stub, just wait for it to reinitialize. Okay, so I'll do a visa booking first of all. What we're seeing now is the live system responding. And just to validate that, I'll do it again. You'll see that that number is incrementing, so it's the underlying database in play there, incrementing that number. It will be the same thing for American Express. But if I now switch to Maestro, what we'll see is the stub gives us a response. So the capability is very easy to manage from a tester and developer's perspective. We achieve this, by the way, by placing what we call an API exit on the MQQ manager. So that gives us a sort of a man-in-the-middle approach to directing traffic either to the stub or the live system components in a very dynamic fashion and a very easy to understand fashion for our developers and testers. So in terms of the demo, we don't really have a huge amount of time today to go into much more detail than that. But of course, if there are any questions, more than happy to take them now.
Yeah, we do have a couple of questions. One is about test-driven development, and really, where does this type of solution fit in with the test-driven development strategy?
Okay. So both developers and testers would typically use this tool. I mentioned already that you can build stubs very early in the development life cycle to build a framework that other people can integrate with while they're writing code. That obviously removes the need for people, i.e. developers, to write individual sort of interface stubs while they're building their code. Gives them a very quick and easy way of actually plugging something in to what the underlying system is going to look like while they're actually writing the code. But of course, that stub definition that the developer has written can easily be passed on to the testing team. So the project can be made available to other members of the team so that when people begin their testing, they have a starting point and they can see what the developer had in mind when they were building this test. And they can obviously take those initial tests as a starting point for a more detailed sort of test suite. that the test department might be producing.
Great. And the final question is really, where do you start?
Okay, that's a good question. It's obviously by its very nature, testing a middleware architecture is complex. Typically, the best place to begin is the area that are causing the most pain, especially with service virtualization. The pieces of the architecture that are the most difficult to provision, the most expensive to provision, and the most time constrained. Often test teams are sort of time boxed if they need access to very expensive third-party business partner test feeds. Often there's a testing schedule. There'll be a calendar where they only have, 2 hours in the week where they can test against that particular component. So stubbing out things like that is usually the best place to begin. Address the painful points early, gives you a great return on investment story, gives you a great way of removing those dependencies and removing the contention on the environments.
Fabulous. And that's all the questions we've had today. So thanks very much for your time, Stuart. Thank you, everyone. Thank you, everyone, for calling in. And we will make this available to everybody to review later. Thanks, G.
Absolutely. No, you're very welcome. And if anybody does want to see the product in a more detailed demonstration, obviously